Uh, we have some finishing work today before exam one. And today the goal is to finish chapter one. I almost finished. I only have a very small section regarding balance bridge. I also sent you some material this morning, extra problems and solution. Today is also the due date for homework number, I think homework number 3. So you can send your homework until anytime, midnight. But today I have to finish to make sure that we finish chapter 1 and maybe do some problems, answer questions, just to wrap up the first part of the course. It's only 2 chapters, chapter 1 and 2. I'll send you detailed exam information today or tomorrow morning, either today or tomorrow morning, with information about Zoom link, about anything regarding exam. And you can ask question. Just a reminder that the first exam 1 is next Tuesday. It's 28. The class time starts at 9:25, but probably it's better that you be around 9:15 a.m. 9:15, 9:20 a.m. about 5 minutes early, because I'm going to start taking roll, and whoever is in class, I'm going to set the exam question. But I'll collect, the collection time is kind of restrict time, ending class at 9, because the class goes from 9:25, until 10:40. So the exam ends at 10:45. Exam ends at 10:45 sharp. I just give you 5 minutes to download, convert to PDF file, and everything. So this is the timing. I'll give you all the information, detailed information. I'll send you several reminders between now and the exam date. Exam is open book, open note, but I mentioned before, please have some kind of print copy or maybe print summary of your notes or book next to you, because if we see you constantly using phone or you're in front of a computer, then I may ask you to stop the exam, because there is no way that I can control this cheating situation when some students start to communicate. How can I control that? I always ask the student, if you want to use your phone because you say you don't have a printer, tell me how to control the cheating situation. How do I know that if the students are talking to each other? So that's something that I have to be a little bit, in order to be fair to class, I have to control the situation by making sure that you are not using your phone. It's just like the in-class exam. In-class exam, absolutely no phone, no computer, nothing. If it's face-to-face classes, at least my courses, absolutely nothing except pencil, pen, and paper. But in this case, and it's closed book, closed note for in-class. In this case, it's open note. You can use note, you can use book. But I have to be very careful about using phone or computer during an exam. If you have any question, you can ask any question today, but let me just finish the last part of the course. I do take roll today, maybe sometime, maybe in the middle or toward the end. Today we finish chapter 2, and after exam, we start chapter 3. If I finish chapter 1 and you don't have any question, I don't want to start chapter 3. So I go over some problems. I sent you some extra problems and solutions for balance bridge. So maybe I go over that. And also, as I said, I'll answer any question you have, any last minute question. Before asking any question, let me finish this part of chapter 2, and then we have plenty of time to ask question about anything. So at this point, I just want to continue chapter 2, make sure that I finish. Just only a small, as I said, just a small topic left, and then I'm open to questions and I'll go over problems. At the end of chapter 2, we talked about delta and y. I mean, why some books they write it as y, like a letter, word y, or y this way. They're both, I've seen both. not to get confused with Y or Y display. You can use both, but it's like a delta Y connection, and we showed you how to simplify. And usually, many cases you can combine resistors as parallel and series, but there are some cases, especially later, if you take our classes, that you can always convert if you identify shape as a delta shape. And delta shape always, sometimes they don't give you triangle shape. Sometimes this is also delta shape. This is also delta shape. In order to have a delta shape, you have three nodes, node 1, node 2, and node 3. They go to different lines. That's the characteristic of delta shape. Anytime you have delta shape, you can convert it to Y shape. For Y shape, you can put a node in the middle and connect to the corner points. So you can always go from delta to Y or from Y to delta. And I gave you one example last time, and I may give you more examples. One application, I mentioned before that one application is power system, of course. We use it in power system, and I gave you one example last time. The other application of Y delta, it's something called, this is the last part of chapter 2. One important application is a measurement device that you find it in the lab. It's a device that we use to measure resistance. It's called Wheatstone bridge. Wheatstone is the name of the person, bridge. It's a measurement device. This Wheatstone bridge has many applications. One of them is to measure, unknown resistance. It's just like a measurement device, unknown resistance. It has a bridge format. So it has this format. It's like a diamond shape. This is called a bridge format with some resistor in the middle. Let's call this one R1, R2, R3, R4, and R5. Okay, from here it's connected to a source. For example, for Wheatstone bridge, you can connect it to the source. Maybe, for example, you can connect it to the battery. Anything. You can place a resistor along the way or just leave it like a direct connection. Doesn't matter. The main part of the Wheatstone bridge is this shape. So from here to here, let's say we connected to a source, V. Okay. What's the situation? By the way, we have a device, we call it ammeter. Let me talk about ammeter. When you go to the lab, we have AC/DC ammeter. Ammeter is to measure current when you go to the lab. So for example, if you have a branch and you want to measure the current passing through the branch, you place an ammeter. I don't want to teach the lab part because they show you in the lab. And usually for the lab, you have to do it based on passive sign. If you use ammeter, there is a plus, they don't put minus, they put a plus terminal. So plus terminal is the entrance. Would you please mute your microphone? The plus terminal is the entrance of the positive current. And deflection shows the value of the current. So they show you in the lab and you actually use ammeter in the lab. This is like a practical physical devices. It's not like a digital measure or anything. We do have a digital analog ammeter. You see it all in the lab. So, but the point here is you always connect ammeter in series according to the format, passive sign format, and you read the current value. But this is very easy. Ammeter has a very low resistance. So ammeter doesn't cause any voltage drop here. It's almost like a perfect conductor. So you read the ammeter. If you want to measure voltage, then you have a voltmeter. Again, you go to the lab, you find it. For voltmeter, you connect in parallel. Like for example, I want to measure the voltage. I connect voltmeter in parallel. And voltmeter has a very high resistance, so it doesn't draw any current. It doesn't load the circuit. It just reads the voltage. Again, it has plus terminal, minus terminal, according to the polarity plus or minus, and you read the voltage value. So voltmeter measures the voltage, ammeter measures the current. In case of resistance, suppose you have unknown resistance. Suppose R1 is known, R3 is known, R4 is known, but R2 is not, and it doesn't have a color code. Okay, you form a Wheatstone bridge. So you take 3 known resistors and the unknown, connect them in this diamond shape in any arrangement. You can put R2 here, 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 doesn't matter. And then select any resistor and connect point A to point B. Place an ammeter here. Ammeter, measuring current. Okay. Place an ammeter here. Choose one of the resistors as variable resistance box. If you go to the lab, you find a variable resistance box. Variable resistance has this notation. It's like a box. So you keep changing. It has a knob. You go 1 ohm, 1.2 ohm, 1.3 ohm. So choose one of the known resistors as a variable box that you can control. The other 2 are fixed resistors, one of them variable, R5 anything. You don't even have to put R5, but usually to protect, you put R5. And then you put an ammeter here. Keep changing. R3 until ammeter reads 0 amp. Keep changing R3 until you have 0 amp. If you don't achieve 0 amp, then it means that your bridge is not operating, like your selection of R1, R3, R4 is not proper. You have to change them. And then you connect to a DC source, doesn't matter. So it provides the current. Keep changing R3 until you reach 0 amp. Okay, once the middle section is 0 amp, as soon as the middle section is 0 amp, as soon as the middle section, the current through the middle section is 0, your reading of ammeter is 0. When this current is equal to 0, I is equal to 0, it's called balanced mode or balanced situation, or bridge is in balanced mode. Balanced. When the bridge is in balanced mode, you can use KVL, KCL. You don't have to know proof, doesn't matter. Actually, based on KCL, I can show you based on KCL. When it's balanced mode, this current is 0. So we have total I, let's say this is total I. It's divided into I1 and I2. If this current is 0, this is going to be I1 again, because I1, I1, there is no current going this way. This is going to be I2. Also, if I1 is 0, this voltage is 0. Voltage is also equal to 0. So plus or minus V1, plus or minus V2, plus or minus V3, plus or minus V4. The balance situation, I1, I1, I2, I2. V1 is equal to V2, V3 is equal to V4. This voltage is the same as this voltage. This voltage is the same as this voltage. Current I1 keeps going through R3. Current I2 keeps going through R4. This is called the balanced mode. Okay, what is V1? R1 I1. What is V2? R2 I2. What is V3? R3 I3. What is V4? R4 I4. But I1 is equal to I3 because it's balanced. I3, I2 is equal to I4 because it's balanced. Divide them up. Divide this one, the left-hand side by left-hand side, right-hand side by right-hand side. So you have R1 I1 divided by R3 I1 equal to R2 I2 divided by R4. Again, I2 is equal to I2. So from here, R1 over R3 is equal to R2 over R4. So as a result, what is the observation here? When it's balanced, R1 R4 is equal to R2 R3. R1 times R4 cross multiplication is equal to R times R3. So in order to achieve balanced mode, the cross multiplication of two resistors across each other, R1 times R4, should equal to R3 times R2. Now R1 is given, R4 is given, R3 is a box. Remember to keep changing until you reach balanced mode. So that you know the value of R3 from the box, and you can find the unknown resistance. This is called a balanced mode. If I want to find R equivalent in this case, R equivalent, under balanced mode, what is R equivalent? R equivalent, again, when it's balanced, R equivalent, this branch is acting like open circuit or short circuit. You have two options. R equivalent, because V1 is equal to V2. So it's R1 in parallel to R2, combination in series with R3 in parallel to R4. Or, because R1 and R3 they are in series, R1 plus R3 in parallel with R2 plus R4. They're both under balanced condition if you use this formula. Or if you use this formula, they give you the same number. You don't need Y delta conjunction. Notice that if the bridge is not balanced, then R5 is part of the picture. Previous example, remember the example I gave you last time? If the bridge is not balanced, if R1, R2, R1, R4 is not equal to R2, R3, you don't have a balanced situation. Then R5 is part of the picture. Then you have to use delta Y. But as soon as R1, R4, as soon as R1, R4 is equal to R2, R3, then the bridge is balanced. And if the bridge is balanced, then you just this branch, the middle branch does not draw any current, and the voltage across it is zero. So you have two options to handle the situation. R1 is parallel with R2, R3 is parallel with R4, combination is in series. Or R1 is in series with R3, or R2 is in series with R4, combination in parallel. That's it. That's called a balanced bridge. I will go through some examples in a moment, like doing some of those extra problems where they give you extra problems. Do you have any question about balanced bridge?
That ratio you established R1 to R3 equals to R4. You use that if there's no
current in the yes. Then it's balanced because this current is the same as this current and this current is the same as this current. Notice that if the circuit is not balanced, R5 is drawing current. When the circuit is balanced, the middle section draws zero current. So you can play with the resistance to make this current zero. You're in control to make it zero. If this current is zero, R5 practically doesn't play anymore. The current is zero, the voltage is zero. So all the current coming from R1, because this line doesn't draw any current, goes to R3. It's not like a short circuit, like a regular short circuit. It's forced, actually, because of the source, because of R3. Even though you see it as a short circuit, but that short circuit is forced not draw any current. It's forced from outside, not to draw any current. It's just like you're walking and you see this wide open pathway. So somebody is standing and doesn't allow you to go through that pathway. That's a balanced situation. Yeah.
So unless we have an ammeter, we can use that.
No, ammeter is just a measurement device. Suppose you're in a lab. How do you know if your circuit is in balance? Okay. When you're in the lab, suppose that you. Okay, I mean, suppose again, let's say you have 1 kilo ohm here, 2 kilo ohm here, and then you have a resistor that is unknown. Then you put, and then you don't know how to measure this unknown resistor. That ammeter is just when you're in the lab, like I'll help you to measure it. So you take this circuit and you connect to some voltage source, like 5 volts, whatever. But I connect a 5 volt battery. And then you place any resistor, anything. You don't even have to just to protect against it. And then you put an ammeter here. You connect this end to this end, and you put an ammeter here. Then you put resistor box. Resistor box is a variable resistor. It's just like a box, and you have a knob, and then you keep changing this knob. But of course, it gives you the value like each knob is associated to resistance. Now you keep changing this resistor. This is a variable resistor. Anytime you see the symbol means variable. You keep changing, and you look at the ammeter. Of course, the circuit because all the voltage source going current, including the middle branch. You keep changing until the ammeter reads 0. Ammeter reads 0, it means that there is 0 current here. And then you have balance. Okay. So ammeter is just measuring. Ammeter doesn't interfere with the resistance or anything. It just reads the current for the branch until it reads 0. Once it reads 0, it means that there is 0 current here. It means that 2K multiplied by resistance box, whatever you are reading here, is equal to 1K multiplied by the unknown. And then from this equation, I find R. You can only apply this when it's balanced. Remember, in the exam, if it's not balanced, you cannot do that. Any other question?
Professor, how do you know what resistance to use, what value to use to make a balance?
That's why you're using resistor box. You just pick two of them, anything, and then you use the variable resistor box. This is a variable resistor box. I don't know if you're taking measurement lab or you're in the lab, there is a resistor box. I mean, sometimes the resistor box is in the form of IC chip, you can changing it. And not chip, they don't use chip now. I mean, they use box. It's just like a knob. This is a resistor. This box, you place the box here, and this box is actually a resistor. But it varies. You keep changing it. You don't know at the beginning. Remember, you have one unknown here. So you connect the unknown. Actually, there are some storage that already put together as a resistor box. If you're in the lab, I've seen that in the lab before the pandemic. I don't know if they still have it. You actually have the whole thing inside the box, and then they give you access to connect the unknown resistor. And then this whole thing has a knob, like has something that you can move around. And then under the situation, somehow those modules that they have the whole thing in the box, they somehow also give you access to the connecting the ammeter, like from here, a terminal that you can connect the ammeter. So you take this whole module, you connect to the ammeter, and then they give you the knob, you keep changing, and then when the ammeter is 0, reading the ammeter is 0, it's balanced, then your unknown resistor based on the reading of they guide you how to do it. So my point here is they put the whole redstone bridge put together as one module, and then they give you the guidance on how to read it. But what I'm saying is, if you don't have that as one module already manufactured as one package, you can build your own redstone bridge. This is the way you do it. You don't need resistor box. You need variable resistor in order to do that.
So we're going to do more examples of this right now, right?
Yeah, but let me ask you, what part of this is you think you need more example? No, I give the example, but I just try to focus on the type of example I need to give you. I mean, what aspect of this bridge is confusing? You have diamond shape. Okay, this is a setup. Okay, R1, R2, R3, R4. If R1, R4 is not equal to R2, R3, not balanced. If it's not balanced, the example I did last time, you have to use Y delta. If R1, R4 equal to R2, R3, it's balanced. Balance means this middle section does nothing. This current is the same as this current, this current is the same as this current, this voltage is the same as this voltage, this voltage is the same as this voltage, and R equivalent. It's either R1 in parallel with R2 plus R3 in parallel with R4, or R1 plus R3 in parallel with R2 plus R4. That's all about the Redstone bridge.
So if you give this to us in an exam, you're gonna let us know if it's balanced or not.
You have to know. You have to figure out yourself. Why should I tell you? Can't you tell? If you multiply these two numbers and these two numbers, if they are not equal, they are not balanced. So why should I tell you? Just cross multiply.
We're going to have like the voltage of the
No voltage. I give you R1, R2, R3, R4. Can't you tell if it's balanced or not? In the exam, if I give you R1, R2, R3, R4, can't you tell if it's balanced or not? Just multiply, cross multiply, like R1 times R4, R2 times R3, they're equal, it's balanced. If they are not equal, they're not balanced. And the circuit is not balanced. I'm not going to ask you to redesign it. Or the only time that I tell you, I say the following Redstone bridge is given. As soon as you see Redstone bridge is balanced, and then I give you 3 resistors and ask you the fourth one. That's why I said, I mean, there's not much I can do about this problem. I cannot make it complicated because I either give you R1, R2, R3, R4, and you have to determine if it's balanced or not. You just cross multiply. Or I give you out of 4, I give you 3 resistors and ask you to find the fourth one under the condition that the circuit is balanced. Again, it's only one formula.
Can you show us an example of it not being balanced?
Last example, last time. I did one problem. The reason I keep saying that because I want you to pay attention when I go from lecture to lecture. What was the last lecture? I did problem, and it's also in the handout. It was in the handout. I used the problem from handout, and I used Y delta. Do you recall the problem I did last time? For Y delta? That was imbalance bridge. I gave you this problem last time. This was a problem from last time. The numbers. Remember, I even put 4, 6, 8, 7, 10. And ask you to find out. Remember?
Yeah, but those are 2 triangles, right? One Y delta and one Y delta.
Okay, is this balance? 4 times 7. It's 28. 6 times 8. It's this is 28. This is 48. Not balanced. So 10 is part of circuit. So how do you find I? Remember I found argument. You have to use delta. I did this problem in class. Remember? I found this one. And then I combine these two. I combine these two combination in parallel series, and I found total arc.
This one is this one delta to y or y to delta?
What do you think?
It's like delta y.
Yes. So this was the example. I can give you 100 examples back to back. They're all the same. I just changed number 4 to 20, 6 to 10, 8 to something. The format doesn't change. I can take this point and extend it. Sometimes in textbooks you see a schematic. Sometimes you get confused because of the schematic. You should not get confused. Like, because sometimes this is a node. Sometimes they extend it. So they show you the circuit. It's the same circuit. And you think, oh, it's a different problem. It's not a different problem. It's just using
So would this be like the RAE equals RA times RB plus RA?
Just give me 10 minutes. Just give me a few minutes. Just say 8. This is the same. It just anytime you have a node like a point, it can take as an extended as a line. So then don't think that this is a different problem. It's the same. Again, cross multiplication. 4 times 7, 8 times 6. If they are equal, it's balanced. If they are not equal, it's not balanced. Let's say I change this one to 12. This problem. So 6 times 8 is 48. 4 times 12 is 48. It's balanced. As soon as it's balanced, the 10 ohm doesn't play a role. This is 0. So what is R equivalent in this case? You have two options. Either say 4 in parallel with 6 plus 8 in parallel with 12. And of course, at the end, you add 5. Or you can say 4 plus 8. Because if it's balanced, you can either add 4 and 8, 6 and 12 combination in parallel. We can make 4 and 6 in parallel, 8 and 12 in parallel combination in series. In parallel with 6 plus 12. This is my example of balance bridge. Plus 5. If I change this number from my last time example from 7 to 12, 4 times 12 is 48, 6 times 8 is 48, it's balanced. If it's balanced, this line doesn't draw any current. That's the best bridge. So if I ask you what's the total current, the total current is total voltage divided by total resistance. What's total resistance? You don't need delta Y. In the exam, before you jump to delta Y, check and see maybe your bridge is balanced. If it's balanced, the total resistance of this combination, it's either 4 plus 8, 6 plus 12, combination in parallel. Or 4 in parallel with 6, 8 in parallel with 12, combination in series. And of course, you have plus 5 outside. This is a balanced bridge. Any question? I'm done with part 2. Now I'm open to questions. I'll go through. I said the extra problem. I'll do those extra problems. But before doing the extra problem, any question about somebody mentioned about review? This is the review. This course I started with definition with units, unit conversion. I do ask question about unit conversion. I talked about circuit quantities. Charge, current, voltage, energy, power, passive sign, non-passive sign, all definitions. You're responsible. Then I introduce independent source, dependent source. Then I introduce laws, KVL, KCL, Ohm's law, Killigan's law. I also talked about power absorbed, power delivered, and introduced resistor, series, parallel, voltage division, current division, conductance, power associated to resistor, everything like voltage division, current division, almost all everything, and finally delta Y. And balanced. That's it. These are the highlights of what I covered in this class. In the exam, if the exam is problem solving, I kill sources. I talked about how to kill sources. Killing sources means independent source, voltage source short, current source open. In circuit analysis, if problems are problem solving, and don't complain later, I'm going to tell the grader to be super careful about this. I'm not going to accept just numbers if it's problem solving. You have to show work. When you show your work, you have to observe circuits. On your circuit, you must have polarities and direction. So for example, if you're solving a circuit in the exam, let's say you have resistor, some kind of another resistor, some voltage source here, some voltage source, something like that. And then if I ask you to find, I specify, let's say find I, and then if you're writing like V1 plus V2 something, I have to see the polarities of V1, V2. If it's parallel, or I have to see the direction, polarities, and directions. If you have something like this, and you say V1 equal to 4 volts, I'm not going to accept it. 4 volts is based on what polarity? In circuit analysis, you don't just circuit analysis is very systematic. You don't have too many special cases. But it's a must that your circuit and your work should match. If you don't show any circuit, and you keep writing I1 plus I2 plus I3 something, without any circuit, how do I know where is I1, where is I2? I've seen it. So even if I don't mention about, if it's multiple choice, no problem. You just find a number, but remember, the drawback of multiple choice is the fact that if your answer is wrong, you don't get any point. At least with problem solving, you get partial point. For me, setup is important. Matching polarities and directions based on passive sign is important. And then if you make some minor mathematical mistake, like adding, subtracting, maybe you end up, instead of saying 4 minus 3 equal to, you say 3. I either tell graders not to deduct point, or maybe collectively, maybe 1 point or 2 points. That's not important if it's essay problem solving. If it's multiple choice, remember, your number should be correct, because otherwise you cannot match. So it's something that, if it's problem solving method, you have to do the setup, write equations, and show your work. One thing about your work should match the circuit. Your work should match the circuit that you show. So for example, if you have if you draw like a soft circuit, and then you have a set of equations that are different, then that's suspicious of cheating, for example. I don't know, because it's unrelated, not even related. So that's also another thing that I ask grader. I have a grader for all classes, but I do in case of dispute or complaint, or I do look at the papers. So that's why I always, when I send information about exam, when you send your exam paper, I send you email of the grader. I send it directly to the grader, copy to me. I want to receive CC to me. A copy of your exam should come to me. And I usually keep it in a folder. And I quickly look at it, but I keep it in a folder. And in case if there is some question or complaint about some point or something that you think that you did right and greater than review point, then you can always ask me to check your paper. I must have your paper. Okay, now I'm going to go into questions, but otherwise I'll do some problems related to bridge. Any question?
Question.
Yeah.
Will our work be on scratch paper that we have to scan and turn in?
Yeah. All the exam should be scanned, converted into one PDF, one PDF file. If you send several files, I mean, online is something that, of course, it has some advantages for you guys. I hope, but you have to follow some guideline. And if you don't follow the guideline, I give myself the right to completely ignore the paper. Because I mentioned many times, it's in the syllabus. It has to be converted. First of all, you have to answer problems in order. I'm going to write it in my guideline. Unfortunately, this is some students, they just read the first 2 lines. When I said, this is almost the second year of being online. I'm not an online person. I'm face-to-face instructor. Maybe many instructors, maybe they have online experience before. For me, this is these 2 years because I personally don't believe in online education, especially science and engineering. But anyway, regardless of my belief, I have to follow the format. I have to follow the situation, and I respect and everything, and I follow. But there are also some guidelines. Unfortunately, with online, I'm not talking about you, but maybe few students, they get into this habit of controlling their own time. Like for their lecture, okay, if they feel tired, they just leave the lecture. In classroom, they cannot do that. You cannot leave the classroom. But with online, they get tired and say, okay, I have other things to do. It's raining. I don't want to listen to her voice. I mean, you just get tired and you just, maybe you keep the Zoom, but you leave the room. Well, I cannot control the situation. However, when it comes to exam, there are some guidelines. And a student, unfortunately, again, they think that they can control the situation. They do whatever they want. I write in syllabus, and I write in my course guideline. And also for exam, please read them. Not just the first 2 lines. Read the whole thing, 1 page. We are obligated. The dean, chair, they always tell us, explain everything. And we always, not just me, and even my colleagues, we always argue that we do explain. But the students, they just don't read the whole thing. Maybe read just keywords or maybe key information. So please read the guideline. The guideline says you cannot leave the room. The guideline says you cannot go blackout. If you go blackout, I don't know. I don't know. I understand. I understand that this is a situation with a network. I may go blackout. I may completely get some kind of problem or interruption with my network. I understand that. But what can I do? I mean, I have to really control the situation. Please try to think of a backup. Use your phone to continue. We have to see you during the exam. How many emails I receive from a student? Do I have to turn on my webcam? Yes, of course, during the exam, I have to see you. Another question, my webcam usually shows above my neck. No, I have to, I mean, properly, I have to see you. Your hand, desk, your workspace, not your entire or anything, just little place that you're working on your paper. Otherwise, How can I control it? I have to be fair to the class. The other thing, I mean, this takes some because I'm explaining the guideline. Since you asked this question, it gave me opportunity to explain everything. So I have to enforce some guideline. And the other thing is sending. I look at the timestamp. It's just like Canvas. As you know, you're all doing Canvas. All your courses are Canvas. Canvas has a time certain, and you have to submit according to the time. You cannot delay. With email, there is no time certain, but I look at the timestamp of your email. It has to be submitted by that time. Otherwise, I'm not going to accept it. It has to be submitted as a PDF. You cannot just send paper, 5 pages, one by one, take a picture. You cannot take a picture and send a picture to me. Convert or scan to one PDF. And then for the grader, because we have so many papers, you have to do it in order. Number 1, maybe first. Suppose you want to jump to number 3, no problem. Just leave some space, maybe 1, 2, 3, and then number 8. Maybe use 8 pages, maybe use 12 pages, I don't know. But when you are scanning, put them in order. If it's multiple choice, answer them in order. Like for multiple choice, it's easier. Number 1 for A, number 2, answer B, so on and so forth. So put them in order because that makes it much easier for a grader and less error by grader. It makes it easier for us. So there are some guidelines that I appreciate if you follow, and it makes it easier for us to grade. One PDF, and I know for a fact that I mentioned several times that in order to investigate your paper later, I must have a copy of your exam. I used to ask to send it to TA, but I was told by the department, we need to keep a copy because they have so many disputes in other courses or problems with other courses. So please send a copy to me. I mean, just CC to me. And you put the email address. And then that's another thing. How many times, please pay attention to I keep sending you Zoom link. Exam Zoom link is not my Zoom link. And then we notice that 20 minutes after exam, there are some students who are not showing up, and I keep sending them email, where are you? And they say, oh, I'm at your Zoom link. Come on, I send it in a guideline. This is a Zoom link of proctor. We have a proctor. You have to go to the Zoom link. You all go to the Zoom link of the proctor. And then they send exam. They don't send it to TA. You have to send the copy to grader, not TA grader. And then I send you that information today or tomorrow morning. Okay, so it's a lengthy answer. Yeah, go ahead.
So after we finish the exam, then we have to take pictures with our, we have to take pictures with our phone to upload it to Canvas or wherever we upload it.
Not Canvas.
Or email.
Email. Convert to a PDF. Use a scanner.
I know, but do we tell you as soon as we finish so that we can?
You tell the proctor. You tell the proctor that I want to upload, so I'm using my phone to take a picture. That's it.
Okay.
Yeah. Maybe toward the end, maybe it's 10 minutes before the end, proctor announces that now you don't have, I mean, it's up to the proctor. Sometimes they say you don't have to announce. Go ahead, within these 10 minutes, if you want to take a picture, just go ahead. And they see you like you're uploading. And some of you may, especially at the beginning, you may want to print the exam and the printer is a different location. No, at the beginning, you might want to go to a certain location and print out. And then you just tell the proctor that I'm going to print my copy. When you mention to proctor, then probably proctor is tracking you down, like probably focusing on the screen, and then if you disappear from the screen for a long time, then they probably inform me, and then I'll try to find out what's going on. So this is something that, by the way, during exam I'm around, you can ask a question by opening my, if it's short, because I don't want to disturb other students. Or you can send an email, have my email handy during exam at that time, or you can send it to on the screen, maybe like a chat. Open your chat, send it to proctor, and proctor can email me. But I think opening mic, if you say question, quickly mention the question, I'll answer, no problem. But I'm around. Any other question? Okay, let me do a quick roll calling and do some problems, homework. Aguilar,
Here.
Alejandro,
Here.
Amador, Arellano,
Here.
Argandona,
Here.
Beltran. Yes, yeah. Bernal,
Here.
Castaneda,
Here.
Castro,
Here.
Claire,
Here.
Contreras,
Here.
Ellie, Estrada,
Here.
Jose Garcia Sandoval,
Here.
Jose Eduardo Garcia,
Here.
Gonzalez,
Here.
Haro,
Here.
Hermosillo,
Here.
Jimenez,
Here.
Levy,
Here.
Leon,
Here.
Macias,
Here.
Melendez,
Here.
Mendiola,
Here.
Monje,
Here.
Moreno,
Here.
Pedro Munoz,
Here.
Sarahi Munoz, Moreno,
Here.
Alex Portillo,
Here.
Robin Rivas,
Here.
Robles,
Here.
Rosha,
Here.
Janet Rodriguez, Marlene Rodriguez, Rojas,
Here.
Rosales,
Yes.
Sabino,
Here.
Samai,
Here.
Siordia, Tran, Valencia,
Here.
Velasquez,
Here.
Villamil, America, Villamil. Not here, Villamil. Okay, Vivaldo,
Here.
Zaragoza.
Here.
Okay, let's do some, I have about 5 minutes. Do some problems from extra set, the extra set I sent you. Okay, let's go to problem 2.107 is easy. I mean, I just managed them. Let's go to 3.25. I'm sorry, 2.25. This is extra set. I sent you this morning. And you don't have time, you don't even have to write, just pay attention because it's in the solution. I also send you solution. Okay.
So it's 2.107. This
It's
is
2.25.
I know, but the one on top, is that supposed to be 2 kiloohms, or you just put 2K?
Problem. Find R if the bridge is balanced. 6 times 2 is 12. R is equal to, because 6 times 2 is 12, so R is equal to 4K. Why 2K?
No, it says 2K. So is that supposed to be the measurement of ohms?
I'm confused. Are you talking about 2.17?
Yeah.
107. Where does it say 2K?
It just says 2K on R equals.
Are you talking about the problem statement or the solution?
No, the statement, the R4.
It says consider the following circuit. Find R if the bridge is balanced. find power absorbed by 12 kilo ohm.
In the diagram, it says 6 kilo ohms, 3 kilo ohms, R, and then 2K. Is that supposed to be 2?
Yeah, 2K.
kilo
Yeah,
ohms?
we are talking about the number. It's 2K, yes. On the schematic, it's 2K, yeah. So 6 times 2 equal to R times 3. 6 times 2 is 12, so R is equal to 4 kilo ohm. Okay, so you have this case, and the question is find V0. And this is 4 milliamp. It's 12, 12, 12, 12. Obviously balanced. It's balanced. Okay? If it's balanced, in order to find V0, it's so easy because if it's balanced, this line is like a short, 12 and 12 are in parallel. You have 2 options, but I just know one of them. By the way, anytime you have R in parallel with R in parallel with R in parallel with R, let's say 4 times, the result is R divided by 4. If you have same resistors in parallel 10 times, it's a value divided by 10. If it's the same, 12 in parallel with 12, it's equal to 6 kilo ohm. Okay, so this 12 in parallel with 12 is equal to 6 kilo ohm. So it's like having 6K here, 6K here. And the question is about V0 voltage. You don't even need voltage division here because they gave you current source, 4 milliamp. So 4 milliamp going, V0 is equal to 6K times 4 milliamp. It's 24 volts. If it's balanced, this line doesn't draw any current, so these two are in parallel. These two in parallel, so this voltage is equal to the current multiplied by 6. Let's do problem 265.
Can I copy
Professor?
this real quick?
Yeah.
Professor?
Yeah.
Why did you divide by 2?
12 ohm in parallel, 12 in parallel with 12. It's equal to 12 times 12 divided by 12 plus 12. I showed you, I just mentioned that anytime you have equal resistors in parallel, 10 times, it's equal to the value divided by the number of times that they are in parallel. Like 12, you have 2 resistors in parallel, they're the same, it's 12 divided by 2. Or you can use the formula and come up with the number. Like if you have, if you have like, I don't know, R in parallel with R, in parallel with R, in parallel with R, in parallel with R. Okay, you can pair the R times R divided and then take the result and pair, or you can use 1 over R equal to 1 over R plus 1 over R plus 1 over R plus 1 over R, so on and so forth. And then inverse it. If you do that, the result is always equal to R divided by 1, 2, 3, 4, 5. If they're equal.
Professor, I noticed in the last question you didn't you didn't have to convert 4 milliamps into amps.
I mean this problem or different problem?
Just the previous one before this.
Oh, problem 2.17?
No, it was a 2.25.
Oh, 2.25, 2.25 here again.
Because
2.5
6 ohm.
is 6 kilo ohm. 6 kilo ohm. We out. The current is coming 4 milliamp. It's Ohm's law. So what is V0? It's 6 kilo ohm multiplied by 4 milliamp. Milli cancels kilo. It's 24 volts.
Okay, thank you.
This problem, as I included, notice that I don't have too many problems in bridge cases. One problem I gave you last time, which wasn't balanced, but this problem, So that's why I just gave you like 2, 3. There aren't too many, even if you take a look at the book, because it's very standard problem. Let's do this one. 2K, 4K, 2K, 2K, 2K. This is problem 265. And then I have 2, 4. And people, as soon as they see this, they think it's a delta. No, it's not delta. Delta Y connection. You don't need delta Y. And then 2K. Okay. The question is, if you stand here and look into this whole circuit, what is the equivalent resistance you see? Equivalent resistance that you see in this case, it's kind of people get kind of, as soon as they see this, they say, oh, delta Y. If you use delta Y, you waste your time. It's not wrong, but you're wasting your time. Because you see a very nice format. First of all, 2K and 2K, they're series. 2K and 2K, series. Maybe at the beginning, when you combine redraw. So I have 4K and I have 4K as a result of combination. And then continue the rest. Do 2 at a time, maybe at the beginning. Notice that this 2K is combined by these 2K, so you no longer have 2K. Okay. And then you want to find R. Okay, these two, they're also combined. You can put it here or here on this side, doesn't matter. 4K. Okay. Again, you can put it here or here, doesn't matter. So this is 4 and 4. 4 and 4 in parallel. 4K. In parallel with 4K is equal to 2K. Again, 2 same resistors. So you can combine these two. It's 2. Combine these two. It's 2. Combining these two as 1. Combining these two as 1. 4. 4. And you're here. Remember, you are here. When you're combining, this is the same node. You're here, you're here. You combine these two, 4K, 2, 2, and you have side, 4 and 4. 4 and 2 in what? Series. 4 and 2 in series. 6. 6. And you're here. Okay, you're here. 6 in parallel. Okay. So first you combine these two as series, 4K. Series, 4K. These two series, 4K. These two series, 4K. Redraw. Then because of this is the same node, if I put another resistor here, maybe delta Y. But in this case, it's just the same node. So you have 4K on this side, 4K on this side, 4K on this side, and 4K on this side. Parallel, parallel. 2 and 2. And you keep the side. Then combination series, combination series. 6 and 6. And then you have 6 and 6, and you're standing here. Finding resistance is terminal based. If you move around, the amount of resistance you see, equivalent resistance is changing. So it depends on which terminal you're measuring resistance. You're standing here. 6K to your right, 6K to your left. You're in parallel.
So on the 2 and 4K in parallel, you just did you multiply them and then divide by 2, or how did you get 6 on both sides? You added them?
4 plus 2, yeah, because series.
Oh, okay.
Yeah, series and series. They are in series and series. Any question here?
Not there, but we're gonna have the solutions to question to homework 3. Like
Yeah. After today, right after today, because it's a deadline, I'll send it tomorrow morning.
Okay, thank you.
Last problem is the current division. This is the case 10 ohm, 2 ohm, 10 amp, and 6 ohm. Let me see if I don't want to go overtime. Is it overtime? No, not yet. Okay, find I0. Find I0 using conductance, using resistance. Current division. I'm just trying to practice current division. Conductance is easier. What is I0? Is equal to, this is 10 amp. It's a branch current. It's the conductance of the branch. Conductance is 1 over, this is ohm, divided by the summation of conductances. Multiply by total current. And you simplify. Using resistance, so this is using resistance. Maybe you don't want 1 or 1/2. Using resistance is you have to reduce to 2. For resistance, you have to reduce to 2. So you keep the resistance in question. Don't change it. But you can combine 10 and 6 in parallel. Oh, 10 and 6 in parallel. So now you have 60 over 16 ohm, 2 ohm, 10 amp. And the question is I0. Now, if you use resistance, you have to reduce to 2. It's the other resistance divided by summation multiplied by notice that if a problem is asking you to find I0 in this direction, you still write everything, except at the end you have to check the current coming from the source. Source determines the direction. It's going downward. If the question is upward, it's against, you just put the minus sign in front. This minus plus, if I give you a say problem, if it's multiple choice, I put both plus and minus to make sure that you understand. If it's essay problem, don't come to me and say, okay, for example, the grader deducted 2 points because I just forgot minus. It's not a second analysis, it's not forgot or forget, or it's some algebraic sign eventually is related to the behavior. It's a characteristic, it's not just a simple math mistake. Simple math mistake is if you, for example, 60 over 16, if you simplify, you make a mistake in decimal point, for example. That's forgivable, but in terms of plus or minus, especially with passive sign, because I did mention many times about passive sign, series, parallel, passive sign, I do really pay attention to those concepts. And let me give you another example. Let's say I have a last example. Let's say I have a voltage, a current source here, a resistor, another resistor here, a voltage source here. I'll just give you a simple example, and a resistor. Let's say we have 2 ohm, 4 ohm, 10 ohm. I ask you to find R equivalent. You can't because of the sources. However, you can find R equivalent after killing sources. You cannot kill dependent source. I'll talk about dependent source after chapter 3. But you can kill independent source. So what you do here, you redraw the circuit. Killing sources means current source out. Current source open. Voltage source short. So here you have a current source open, 2 ohm, 4 ohm, voltage source short, and 10 ohm. Okay, now you find R. What is R? Go to the end. 4 in parallel with 10. Combination in series with 2. So it's 40 divided by 14 plus 2. And of course, you simplify. That's my last example. I send you solution set number 3 tomorrow morning. Exam information tomorrow morning. You can ask any question between now and Tuesday. I try to answer questions very clearly, especially before exam. The reason sometimes it takes time because it gets mixed up with homework problems. So please make sure if you have a question next to EE2 and T40, put the word question. So I quickly answer the question. I'll try my best to quickly answer the question.
I have a question
if you
on
have
voltage division.
Yeah, go ahead.
Sorry. Because when there's no independent voltage source, could we still use voltage division?
When there is dependent sources, right? When there is independent. Yes.
I mean, that was a different question I wanted to ask too.
If there is no independent source and there is no dependent source, circuit is not active. So there is no point of asking voltage division. I mean, you have a bunch of passive elements, right? You must have something, some action in order to write voltage division. Voltage division is based on having a single source. That's the must. You must have a single voltage source. If you have multiple sources that you cannot combine, like for example, if you have a case that you have a voltage source here, resistor here, another resistor here, another voltage source here. Notice that in this case, I cannot combine these two. If you still think that I can combine these two, you still have a problem. These two voltage sources are not in series. In this case, I cannot use voltage division. Voltage division, you must have this format, a source and bunch of series loop. Then you can use voltage division. The question comes if you have, let's say, a dependent source, a voltage source, and a resistor. Let's say you have 2 volts, 10 I1, R1, R2. Notice that you can still combine these like a 2 volts minus 10 I1 as one voltage source and multiply by R2 divided by R1 plus R2. The problem here is you have I1 and you have to substitute. So that's why my advice is anytime you have a voltage source, if it's dependent, and even if you have a single loop, just write KVL. It's easier. To answer the question, if you have a series circuit with a dependent source, yes, you can still write voltage division, but maybe it's not too helpful. If there is no independent voltage source, no. You cannot write voltage division. You must have current source or total current coming into the circuit and parallel circuit for current division. And you must have a voltage source or voltage provided. Sometimes they may not even show. No, you have to get used to this notation. Let's say I have a circuit here and they put this notation and they say plus or minus 10 volts. It means that this circuit is connected, but you don't really need to see this part. You just need, it doesn't mean that it's open. It means that 10 volts this is connected, but and sometimes they do it this way. Sometimes they do it this way.
Yeah, so
For
if there was more,
yeah,
there was more like resistors in parallel, could we then use voltage division since we have that notation?
Yes, you have to reduce it to 1. Notice that if you have to go back and forth sometimes in order to use voltage division. Like for example, if I have this resistor here and maybe a resistor here, and a voltage source plus or minus 10 volts, maybe some voltage. I want to use a voltage across each one of them. Yes, you have to combine them in parallel first, reduce to 1 and 1, and then use voltage division.
So it's just the notation that makes me think that it's not possible. But once I see through that, it becomes easy to use the voltage division. I see now. Thank you.
Yeah. Okay, if you have any question, please ask. Otherwise, have a good day.
Professor?
Yeah.
Is it possible if we can go over a problem in the homework?
Right now, it's the end of the lecture. Which problem?
I was gonna just ask about number 4.
Okay, if it's number 4, what time is it? Because I have another class coming soon.
If you don't, I can just
No,
email.
no, wait. Problem homework number 3. Homework number 3, problem number 4, you said?
Yeah, yes.
Okay, here, I can do that easily. Again, because of drawing, people immediately think that this is delta y. It's not. Always try to think about series parallel first. Forming an angle doesn't mean it's delta y. 4, 8, 4, 3, 3, 5, and 6. Okay, this is a terminal. Go to the end. Always start from the end. Go to the end and keep on combining. 4 and 8 in series. I don't have time to simplify, just write. Combination, you can redraw, but try to make it like gradually get used to just visualizing. 4 and 8 in series, combination in parallel with 4. In parallel with 3. In parallel with 3. You have 3 and 3 and 4 in parallel with 12. Find this combination. Then once you find the whole thing, remember you can extend this note. Combination is in series with 5. Again, after the whole thing, combination is in parallel with 6. So you go from the inner part toward the outer part. So here, 4 and 8 is equal to 12. 12 in parallel with 4, 16, 4, and 4 is 3. Actually, this combination, if you do it correctly, is 3. It's 3 and 3 and 3 in parallel. Remember, I just mentioned that R and R and R in parallel. This combination is equal to 3 divided by 3 is equal to 1 kilo ohm. All the numbers are kilo ohm. Then 1 kilo ohm plus 5 kilo ohm is equal to 6 kilo ohm. And 6 kilo ohm in parallel with the final 6 kilo ohm is going to be 3 kilo ohm. So you start from the end. 4 and 8 is 12. In parallel with 4 is 3. Then you have 3 way parallel. 3. This combination is going to be 3. And then you have 3 kilo ohm in parallel. So it's going to be 3 kilo ohm divided by 3 equal to 1 kilo ohm. With that 1 kilo ohm, notice that this point, you can move it here. It's just a schematic, they use it in the book. It's the same thing. I mean, connecting from here to here is the same as I do this because this is short circuit. It's 3. So I have 3 kilo ohm in parallel with 3 in parallel with 3. It gives you 1 kilo ohm. 1 kilo ohm plus 5 is 6 kilo ohm. Then the combination is in parallel with 6 kilo ohm. Okay, I really have to stop to go to my next class. Okay, and
Thank you, Professor.
okay, no problem. Thank you. Thank you.